Hey everybody, this is an unboxing of the Raspberry Pi. As you can see, I ordered mine from Element 14. Got here. Safe and sound, in one piece. Very good sign. Anyways, here's a little box that it comes in. As you can see right here, it has a little documentation for getting started. For your free download, it says go to this appropriate website, raspberrypi.org/downloads. Because it's just a board. If you want to be able to boot from it, you'll need to have an operating system of some sort to boot from. And with that, you'll need an SD card. Anyway, here's a logo. Awesome logo, Raspberry Pi. Of course, we have our Element 14. A product placement there. I definitely recommend them. We'll open up the top here, and we'll see that it's enclosed in a nice anti-static bag. Very, very handy dandy. Raspberry Pi regulatory compliance and safety information, just kind of warnings, very common sense stuff. You know, don't expose it to water, obviously. Keep it in well ventilated areas, and take care whilst handling to avoid mechanical or electrical damage. Make sure, you're well grounded. Destaticify yourself if you can before you handle the board and stuff of that nature. And so, yeah, there's that. Alright, so now let's actually get this puppy out of here. So as you can see, it's in a nice shielded bag. And take this awesome, luxurious device out of its casing. Alright, there it is. Raspberry Pi in all its glory. Okay, so here we are, Raspberry Pi. Copyright 2011 to 2012, it looks like. There's a nice Raspberry Pi logo. Alright, so let's just take a look at the connectors here. So right here, you can see there's a power through micro USB, so you want to make sure you have one of those to provide power. 5 volts. You want to make sure you have a power supply source that can amply provide enough amperage for this device. It's recommended to at least have a 1 amp. My goodness, this autofocus is not working. It's recommended to have at least an amp of power. There we go. Amp of power for providing power to this. Over here we have a little spot for inserting ribbon cables and whatnot. We have our header connectors, our GPIOs, and all that right here. We have a standard RCA video jack here. Considering this was built for educational purposes, that right there is for the older style TVs, which are probably plentiful in some of these poorer nations because they got all the hand-me-down equipment. Over here we have our audio. Standard RCA jack. It's just headset. It's no microphone integration into that as far as I know. Go over here on the other side here. We have USB. We have 2 USB slots. Obviously you want to take care as to what you plug into it because it's going to be sharing the amount of power that you're pulling from the actual port that you have plugged in on this side. If you're powering here, the client USB. This, of course, is your host USB. You can plug in keyboards, mice, Wi-Fi's. You want to be careful with what Wi-Fi devices you plug into it because certain Wi-Fi's are going to be pulling a lot of power, and this is not going to be able to amply provide that much power. So you just want to take that into consideration. Also, there's going to be USB hubs you can use for powering devices like that as well. Anyways, over here we have our Ethernet connector. You can plug in, obviously, an Ethernet cable into this, plug it into your switch, router, whatever, and it'll provide 10/100 megabit, although I'm sure it's going to be 100 megabit considering what uses 10 megabit nowadays. But it's not a gigabit. So if you're looking for transferring tons of stuff over this device, it's not going to happen. Although 100 megabit is probably going to be ample for a lot of uses. And then over here we have, well, HDMI, the winning video interface in my opinion. High definition, you can plug it into your TV, monitors, capture cards, tons of things. And has a standard size slot, which is very nice. So you guys use your standard cables and all that for that. So yeah, very, very basic. You have the chips here. You have your CPU and everything kind of GPU and all that kind of integrated in there. Go show you power regulation and all that going on over there. And your other chips, which controls USB, Ethernet, and all sorts of other things. And now we'll take a look on the inner side of the board here. You have your standard size SD card slot. So that's where you're going to be plugging in your SD cards you have formatted with the appropriate operating system. And you can look at all the other, awesome circuitry down here. The resistors, chip boards, transistors, who knows what else. Some capacitors looks like as well. There's the unboxing, the Raspberry Pi. I need to get an SD card formatted and configured and set up so I can get this puppy running. Get some all sorts of cool stuff on it. Heck, we wouldn't stop Puppy Linux on it. You guys. Yeah, there you have it. Raspberry Pi. And of course, when you're setting it down, of course, be sure to put it on a surface that is appropriately capable of handling it, because if you put it on metal, bad sign. Bad karma. Just bad everything. Freshly transferred copy of all the files from the website, Raspberry Pi. Go to that. Download their default installer. I'm just choosing that for now just because I want to see kind of how it runs just with the default installation before I start messing with other distributions and whatnot. Anyways, here's my SD card reader, and inside that is included with a 4 GB SD Class 6 card. I'll take that out and I'll take this with me. There it is. Oh, it's glory. I guess they only need write access. I'll leave that in the up position so that way I can write to it. Anyways, we'll come over here to our Raspberry Pi. Still sitting nicely on its anti-static bag, mind you. As mentioned earlier, you can look on the underbelly of the board. And right here, we have our SD card slot. So, I will plug in the SD card just like so. And it's connected. Okay, now time to give it some power. Hook up our HDMI, keyboard, mouse. Let's give this thing a test go. Have the HDMI plugged in. Basically just have the HDMI and then put my finger on the back of the actual connector because I didn't want to put too much stress on the board. Alrighty, here we are. Found an angle that kind of worked. Anyways, USB's plugged in, Ethernet plugged in, HDMI plugged in. Now for our power. There she is, plugged in, all on, lights are on, blinking, good sign. And yeah, so anyways, if you're wondering what the different lights are, they are as follows. From the right of the screen, we have a 100 link indicator, letting us know that it's connected to the line at 100 megabit. We have a link letting us know we're connected to the network and the activity therein. We have another indicator that specifies FOX, not sure what that one's all about. Then we have a power and an action one. So of course if there's power it's on, and if there's any CPU usage, I'm guessing that's what that other indicator is for. So, that's that. Now we'll come up here to the screen that we're now being displayed upon. And check it out. That's the installer that I was talking about. And it has several different options. You have Arch Linux, which is a very minimalistic Linux distribution that is all about kind of what you want your system to be about. So basically, if you're creating a custom system from scratch, that's what you probably want to do. Like if you don't want any extras, if you don't want a desktop interface, you just want kind of command line and want to be able to install whatever it is you want on it, that's one for you. And that's going to give you the most free space, obviously. Then below that you have OpenELEC. That's a multimedia distribution. I don't know much about it, but from what I've seen and read about it, it seems like a pretty kick-butt distribution. Maybe I'll try that at some point. Then below that you have Fedora, which is a twist on Fedora Linux, obviously optimized for the ARM system and Raspberry Pi. Below that you have RISCOS. Below that you have RASP BMC. which is another multimedia one managed by a 19-year-old college student as of this recording. Then below that you have Raspbian, which is a optimized ARM6 compatible Debian Linux operating system. Those are the default operating system choices they give you here. And for this initial test, I'm going to go with Raspbian because that one has the optimizations for the floating enhancements of this ARM chip. So for performance reasons, I'm going to go with that one just to see how fast I can get this thing kind of running. So, bring a keyboard, and I don't know what I just did. Hit a key, we have a blank screen. No signal. That is not a good sign. Well, so far I'm already having a technical hurdle. We still have indicators going on. I'm going to reboot this thing, which consists of me unplugging USB, plugging back in. Anyways, let's try it with the mouse this time. Raspbian. Install OS. Warning, this will install the selected operating system. All existing data on the SD card will be overwritten. So make sure you don't have anything important on the SD card, obviously, if you are going through with this. So I will push yes. And there we go. It is now writing the image to the SD card at about 3.4 megabytes a second. Alright, here we are at our Raspberry Pi configuration software tool, raspi-config. So we have several options here. You can ensure the file system has been completely expanded right there. You can change the user password from the default, as mentioned earlier, is Raspberry from the username of Pi. Enable boot to desktop if you don't want just a command line. I personally like the command line. Internationalization options, you probably want to set that up, at least for like time zone. So I can change the locale, basically language and region settings to match your location. Looks like it's fine, I can read it, it's English. It's awesome. Okay, change time zone. So I want to change the time zone. We'll click that. Okay, so I'll select my area. I'm currently in the US. And please select city or region corresponding to your time zone. So Pacific New would be where I'm at. So there we go. It's now been changed to the appropriate time. Awesome. I believe it gets the time from the internet, just in case you're wondering. Because I don't believe it has a built-in clock for time. Doesn't keep track of that, doesn't have a battery or anything like that. So if you don't have it connected to the internet, it's not really going to be able to keep track of time. Just a heads up. Or connecting to a local network of some sort with a box where you can pull the time from through, the protocol, through the appropriate protocol. You can enable the camera if you have the camera module to plug into the GPIO header area. You can add to RasTrack, which is a online Raspberry Pi map tracking system. That looks interesting. I'm gonna have to definitely look into that, because I'm guessing it, shows who has a Pi and for what, maybe what they're using it for. And you can just kind of see who in your area has a Pi, and maybe you can even collaborate together with some cool Pi projects. Not sure what that's all about, that'd be cool if it was. Overclocking, that configures overclocking for your Pi. I'm not going to do that because I don't have a heatsink for it, so it's going to be completely nullified and void. Advanced options, I always like looking at that. Overscan, hostname, memory split, SSH, and update. So this allows you to change how much memory the GPU has compared to how much system memory you have, which is very, very useful, I feel. Especially if you're going to be getting into gaming and stuff. This could definitely be very useful to set up. So I'll just keep it as default for now because I don't want to, cause any problems by changing too much settings from the get-go. SSH, of course I want that enabled. Started, it's enabled, in case it wasn't already. About config, it's a straightforward, okay, cool. Yeah, I think it's everything we need to have going for now. So add to RAS track, enable camera. Alright, so we'll finish the configuration, and now we're in the freaking command line. So if I list what's going on, see where we currently are, and of course for our first real command, rename -a. Sorry, one-handed typing right now. Oops. Where did the S come from? I'm sorry. I don't even know what that did. Hopefully I didn't do anything detrimental. Okay. Anyways, we have our, well, there it is, uname. Check it out. Linux Raspberry Pi 3.6.11 plus, number 474, preempt, Thursday, June 13th, the time of 17:14:42 BST 2013, ARM version 6.1, GNU/Linux. I am running Linux on my little credit card sized Pi down here. So that being said, let's go, I don't know, start X. So we can actually get a GUI and check out what's going on there. Whoa, tons of commands. Tons of debugging information, I should say. Tons of standard output. STD, OUT. There's a Raspberry Pi logo. Hey, booted up nice and quick. Obviously not running GNOME or anything like that. I believe this is, what is this? LX DX maybe? Anyways, there's all it is. You have Wi-Fi configuration. If I bought a Wi-Fi card to go along with it. I have Python, the Python interface for doing all sorts of crazy stuff with it. Debian preferences, Scratch for basic programming from what I hear. The Pi Store. That's going to be interesting to check out, see what that's all about. You have a terminal, LX terminal to be precise, OCR resources, Medora, and I guess the standard IDLE, and there's also version 3. So it's probably like 2.7 or 2. Whatever it is. So the Pi Store looks a lot like Debian's, actually Ubuntu store from the first glance, but obviously as a new asterisk, that would be a very useful thing to have. So yeah, Raspberry Invaders. Cool. Web server, Pi 3D, programming. So, not too shabby of a setup from the get-go. Don't know what that's all about. The loading indicator in the corner is taking forever. So yeah, there we go. We have our thing set up, DevTools, apps, games. Check out some apps. Alright. So, I don't even know what the default browser on here is. Internet. Oh gosh, doesn't have Chrome or Chromium or Firefox. Tisk. Midori. Let's see what that's all about. Maybe it's an equivalent. Okay. Not liking the likes of that. Click, it's taking a little while to open up. Okay. It appears to be a minimalistic browser. Anyways, I should have internet. I didn't even check for that. DuckDuckGo. Nice. So we'll do a little test search. TEST. Enter. Test of DuckDuckGo. And we have internet. So, there's Raspberry Pi. All its glory. So be sure to get one of your own and do some crazy cool testing. See if we can do a speed test. I don't even know if there's flash enabled on this by default. I feel like I should be like jumping over to an FF MPEG type output here. Is there the terminal to see if FF MPEG's installed on this by chance? Okay. Well, for that matter, AV codec is probably what it is. Or AV convert. Not found. Maybe it does have FF MPEG. Nope, doesn't have either of them. Crap. Well, something to install. Would be curious to see how encoding performance does on the Raspberry Pi. Hopefully I wouldn't completely overheat it. Peace out.